So I'm here to talk to you a little bit about a project that I worked on as part of my dissertation at BYU, and we ran a citizen science project. Many of you here are familiar faces from that project. It's great to see you all again. So we collected, we had about 200 volunteers come and collect water samples from about 250 sites across the entire Utah Lake Watershed in a single day. And it was a huge effort that was only possible from many different groups participating. I have a long list of names on a PowerPoint. But we were able to understand some really unique things about Utah Lake Watershed from that effort. And so the first thing that I want to talk about is where are the solutes coming from? And so we're able to generate sort of a heat map of where the solutes are coming from. And by solutes, I'm specifically referring to nutrients and salts in the water that are pollutants that are going into the lake and affecting the lake quality. And some of the findings from that were that lake tributaries, streams that originate in the valley that don't come from the high mountain elevations, but these smaller streams like Mill Race and Dry Creek, they are much higher in solute concentrations than the streams that are fed by the snow melt. And part of that is attributable to the really unique chemistry that happens in the groundwater in this basin because water leaves by evaporation and doesn't flow out to the ocean to sort of flush out the soils. We have salty groundwater here. And the other contributing factor is the really high concentration of urban areas. Some of the really bright spots on the heat map where a lot of solutes are coming in are tributaries that are bringing wastewater treatment plant water. We have one little bright spot that's a Midway fish hatchery, a ton of nitrogen coming into the streams from point sources like that. So the next thing that, because of the unique nature of this project, we're able to understand a little bit about the nature of these sources and how predictable the different solute concentrations are. So in some cases, you know, ecologists love to say like, oh, well, that depends, and it's too complicated to understand. But there have been some studies that indicate that there are consistent patterns in stream solutes, and so we wanted to see whether that was the case in the Utah Lake Watershed, and it turned out to be true for some of the streams that we measured and for some of the solutes. So for example, chloride was pretty consistent. Places that had high chloride levels always had high chloride levels, and vice versa for low chloride levels. Whereas the solute phosphorus, that's a nutrient that enters Utah Lake that they talked about with the harmful algal blooms, phosphorus was less predictable and less persistent through time. So we're not able to predict from a single sampling where phosphorus concentrations are going to be highest. And so, yeah, I invite you to come stop by my poster. We have a website that you can visit. This study was recently accepted for publication, and so we'll be sharing that on our website shortly. And yeah, if you have any questions, you can come see me on my poster. Thanks.